Hello and welcome back to the latest episode in the series of videos that we are putting together discussing how to design and develop small mini games, and in the process learning about programming and game mechanics and game rules. In this particular episode, we are going to continue our journey on the RTS game that we started, and we are concentrating on how to improve the visual aspects of the collector, the storage, and the resource units, as well as the NPCs ability to detect and attack the player, as well as the player's ability to attack the NPC. So having said that, let's go ahead and jump right into the editor and take a look at how all of these things are put together. All right, so here we have Unity Editor once more. Let's go ahead and do a quick run through of everything so we have an understanding of how things will look at runtime, and then we'll jump into the actual code behind and the design aspects of it. So I'm going to go ahead and run this, and of course, the actual runtime whenever recording through Zoom, for whatever reason, is very flaky, but in real time, it's very smooth. So here we are going to go ahead and find our resource. So none of these things have changed as far as the logic, the finding logic of the resources. But what has changed is how the collectors, the resource, and the storage facility behave. So notice that the storage or the collector came back to the storage, and now the collector stored a unit of resource that it collected from the resource group over there. So basically what's happening in this particular version, in this iteration of the implementation, is that we are visualizing the removal of the resource unit from the resource group, and we are also visualizing the storage representation of the resource unit inside the storage facility. Okay, so that's a very cool stuff. We can jump quickly over here just to visualize how that's done on the collection. So right there, it just picked up a resource box unit, and now it's going to go ahead and store it in the storage facility. And over here, of course, the NPC does pretty much the same thing. So notice that over here, this particular collector already has removed a bunch of resource units, and it just picked up another one, and their own resource storage gets the same behavior. You might have glimpsed at one of the NPC attack modes right there. So now if we get too close to our NPC characters and we are in range, they would basically go ahead and get into the attack mode, and they're going to start shooting us. Similarly, before we jump into the code, notice that our player character has been updated as well. What I can do to make this more clear, we can jump into the design view, and notice that we have updated the prefab to incorporate the cannon over here. Pretty much it's the same structure as we did for our enemy in our previous episode, but we did it on the player character. So I'm going to go ahead and use the T key on the keyboard to basically get into attack mode. And what I'm going to also do is use the spacebar to simulate shooting. And as I click on the spacebar, as long as I have bullets available, is going to go ahead and shoot the bullets. Then there's, of course, a load time associated. So there's not a continuous spawning of the bullets. Right now, I'm out of bullets. So what I need to do is go ahead and get to the storage and reload. And notice that while I'm at the storage, the resource units are getting removed from the storage, and that basically means that I have more bullets now. So each one of those resource units is programmed to contain 3 bullets, and I'm not sure how many we collected, but there we go, it's on the inspector. So we have 21 bullets right now, so we probably have collected 7 resource units. All right, so now that we have a good understanding of the runtime and basically what we are trying to do, the next step is to bring up the source code and kind of go through the source code and see how everything has been put together. Okay, so in the resource controller, pretty much most of the structure of this class has been the same. The only difference is that notice that we have added these 2 attributes, a resource index and a collection of transforms that's going to be pointing to each one of those resource units in a resource group. This is how we are going to simulate the removal of the resource units from the resource group. So we need to have some sort of a pointer, a reference to those particular resource units, and basically at a particular given time, we either activate them or deactivate them. In this particular case, since this is the resource controller, we are listening to an unfinished collecting event that basically gets raised by the collector object, right? And this is, we are adding in the collector object, all we did is that we have incorporated 2 new events, one of them being finished collecting and the other one being finished storing. And what we are doing over here is that after each one of the tasks, whether we are storing the resources or whether we are collecting the resources, after we finish that particular task, we are invoking that particular custom event, and whoever's listening to it, obviously, or whoever's subscribed to it, is going to handle that particular functionality. In this case, in the resource controller, we do care if whenever that event is being raised, and basically we are handling what we want to do based on this delegate function that we have, right? So first of all, we check to see if the resource ID that the collector is collecting from belongs to us, right? So we need to double check because there's all of them are sharing the same code base and etc. So there's a way that you need to identify which resource is actually being removing the unit, right? So that's being handled by this. Next, you do some accounting over here, making sure that your inbounds, so your index is not below 0. And if that's not the case, what we are doing is that we are deactivating that particular resource unit associated or listed in our collection. If we do go below the index value, then pretty much we have depleted this particular resource. And what we are doing is that we are raising a custom event on the resource controller itself, and we are telling whoever's listening to us that, hey, this particular resource has been depleted, and this is the location of the resource that got depleted. This is the ID of it, and it used to be associated with a particular storage ID. So a resource is usually associated with storage ID, the way it's being implemented over here. So this is kind of like the only code that has changed over here. And I'll probably at some point I'm going to share all of this code base with you guys. So for right now, if you're just following along, go ahead and follow along. But I'm planning on releasing the code base to a repository where you can download and study it on your own. Okay, so let's jump back to the IDE and let's take a look at the resource prefab. So in the resource prefab, we have this controller that we were just looking at. And the controller pretty much has that collection of transforms, and the transforms are basically pointing to the resource units as you see over here. And basically what's happening is that within the code, whenever that particular event has been invoked, depending on which index you're on, which resource index you are on, you either get, in this particular case, you get deactivated. The same concept and the principle applies to the storage unit, right? So the storage resource controller also is handling similar logic. The difference is that it's going to both enable and disable the visual part of the resources. So let's take a look at how that's done. So jumping to the storage resource collector. Again, over here, by default, we are setting all of the reference transforms of the resource object group that's associated with this storage to false, meaning that they're not going to be visible. And then anytime this update storage resource function is being called, then we determine if you are storing or not. If you are storing, then what we are doing is doing, again, some accounting over here, making sure that our resource index is within bounds. If it is within bounds, we go ahead and activate that particular resource unit and then increment our index. If we are not storing, it means that we are retrieving the resource from the storage. In that case, again, we also check the boundaries, making sure that we are not going to go below 0. And if that's the case, meaning that the bounds have been checked, we go ahead and use the resource index to deactivate that particular resource unit. Okay, and this particular function is being called. We can actually right-click here and say, not go to definition, but find all references. And over here, you see that it's being called in 2 different locations, both of them at the storage controllers. So if I click on the storage, the second one, this one says, go ahead and get the resources. I'm sorry, this one goes and says that go ahead and store the resources. So anytime we finished storing, this is an event that we are listening to. So this is coming from the collector controller. So in the collector controller, we also have added a couple of events, custom events here, one of them for finished collecting, one of them for finished storing. So on finished storing event, this is on the finished storing event that we are listening to at the storage controller. We again need to check and determine that the storage ID is the same as the storage ID that's being associated with that collector. And if that's the case, go ahead and update the storage resources. And we are not passing any parameters here because by default, the storing Boolean parameter that we're supposed to pass is true. So if you don't pass any parameters, it's going to take the true value. So going to the definition over here, what it does is that it checks the bounds and sets that particular transform at that particular index to true, which basically displays that. Similarly, when we get the resources, this is when the player goes to the storage facility to retrieve the resources. So when it does retrieve the resources, this code was explained in our previous video. So if you need to have an explanation, please go watch the previous episode. This is the same code. Basically, the only thing that we have added is this one line of code over here, which is accessing the resource controller, and it's updating the storage resources. And we're passing the parameter called false, where basically it indicates that now we are going to be removing resource from this particular storage, and basically it does again some accounting and checks the bounds over here and sets that particular resource index to false. So basically it disables it, so you don't see it in the actual level design. So going back to our runtime, and if the player goes to the storage facility, notice that this is when the false parameter is being set. So we are deactivating the actual resources collections associated with this. And if a particular collector comes, so we have depleted all of the resources. So notice that the collectors are basically waiting over there and they're in idle state since there's no more resources to collect. Okay, so this is showcasing that. Now let's go ahead and take a look at how the prefab for the storage has been put together. So what we have done is just added this storage resource root component basically to object to it. And basically this is similar to the root store, the resource root. So it's a copy of this, and it's now also associated with the actual storage over here. And what it has is that we have our own storage resource collector, which we already discussed. And this has a reference to all of those transforms over there. And basically upon the update storage resource function being called, whether we are storing or not, is going to determine which one of these guys should be on or off. So if I go ahead and deactivate the door for a second, you will see how this will be visually represented. And one thing to keep in mind, by the way, is when you're designing your levels, your units, your structures, whatever it is that you're designing, you need to understand how your design of a particular game object is going to affect the actual coding and the logic and vice versa. So in this particular case, it's rather simple, but still you need to take into consideration what's happening here, right? So we do have like a visual representation of resources already predefined. Can we make this more sophisticated? Yes, we can. Can we make it more dynamic and more automated? Yes, we can. But the code obviously is going to get more cumbersome. And for this particular illustration and for this particular video demonstrations, I don't want to make things too complicated. I want to have the concepts communicated rather than doing too many complicated code illustrations. Anyway, here we have the actual visuals. So that's how it's going to look when it's totally full. And then basically as each one of these objects become deactivated, you would see them similarly, right? So let's say if you deactivate this particular object over here, that's how you basically control the removal or the addition of a particular resource unit into the storage. All right, I'm gonna set this back to true so it doesn't change anything on the main prefab. And going back to our game over here. And I think I'm going to pause for a second here. And when we come back, we'll discuss about the attack mode of the player and the attack mode of the NPC. Okay, guys, so here we are going to take a look at the enemy NPC. And right now I have paused the runtime. This will basically illustrate the existing structure of the enemy NPCs. And also you would notice the this vector, which is utilized by the nav mesh agent. And the nav mesh as far as showcasing where this particular agent is going to be traveling to and the travel point, the destination of it over there. All right, so we have covered that in the previous episode. So go ahead and take a look on the previous episode if you want to learn more about how the nav mesh agent and the nav mesh have been put together to allow the NPCs to basically roll around the environment. Here, we are going to take a look at the enemy controller. So we did expand this quite a bit. Most of the code over here is already discussed in the previous in our previous episode. So go ahead and again, please take a look at that for the explanation. But we did add a couple of new behaviors here. One of them is whether the enemy is dead or not. We have also created an enemy attack controller and an enemy health, which is going to be responsible for keeping track of the health of the enemy. In fact, let's start from this class because it's a very simple class. So everybody by default is going to have 100 health. And then based on if a bullet hits your body or not, you're going to lose about 10 units of health. So you're going to lose 10 units of health. Over here, I have a debug statement, which basically is utilized for debugging purposes, right? It gives me the name of the enemy that was hit, which bullet hit it, and the actual new value of the health. Going back to the controller, so the enemy attack controller, we already have seen this in our previous episode. Nothing has changed here really, so it's still doing what it's supposed to do, but I can give a quick overview. So we have a reference to the animator, we have a number of bullets that the NPC is going to have, and we determine whether we are in attack mode or not, and this gets set by the controller, the enemy controller. And basically, if you are in attack mode and we are ready to shoot, we utilize a coroutine to spawn the bullets, and we have a reload time of 2 seconds. So going back to the enemy controller over here, let's take a look at the update function. So over here, we check to see if our health has been is below 0. And if it happens to be below 0, then we are dead. If we are dead, we are going to set the dead parameter in the animator. And this is going to simulate another animation which I created that basically shrinks down the NPC pretty much to 0. It kind of disappears from the screen. And then, of course, we have to destroy the game object from the memory. If the player is inside, pretty much we do the same things. This is where we tell it to, okay, you're ready to attack. Go ahead and now attack it. And we pass in the true parameter. And that way, the enemy attack controller will execute this and start spawning the bullets over there. This particular function was discussed in the previous episode, and this is important because as the enemy NPC is trying to navigate the mesh, there's going to be some places on the mesh that might not be accessible. And if that's the case, we want to go to the next scouting point. And these scouting points have been randomly generated at the start when we initiated the whole the game over here. Now jumping over to the player attack controller. Over here, pretty much we are doing the same thing. We are checking to see if the T key has been pressed on the keyboard. If that's been pressed, we are now in attack mode. If we are in attack mode, then we determine to see if the space key has been pressed. If the space key has been pressed and we are in the attack mode, then we can go ahead and shoot. Over here, we determine to see if we are ready to shoot. This is the reload, the flag that basically controls the reload time. And if we have enough bullets, basically if we have more than 0 bullets, then we can go ahead and start spawning the bullets and shooting towards wherever we are directing. All right, and that's it. And let me go ahead and stop sharing my screen. Cool. So these videos are becoming a little lengthy, but there's a lot to explain over here. And I'm going to, at some point, also release the source code for you guys so you can actually download the source code and study it. It's going to be easier that way to follow along the video, take a look at the video, and also have access to the source code. So I'm still planning to see how that's going to be done. In the meantime, thank you for stopping by again, and make sure to like and subscribe. In the next episode, we are going to enhance and incorporate some graphical user interfaces and illustrating how we can display information back to the user. All right, have a nice one and talk to you guys soon. Bye-bye.